Hello guys, welcome back to our channel Vansh Patel Academy. How are you all? I hope that you all are fine. In previous video, we have done the we have started the chapter number 9 light. So there is some glitch, students. Okay, in previous video we have done till to the standard laws of concave mirror and the ray diagram of concave mirror. In this video we are going to start with the standard laws of convex mirror, the ray diagram of convex mirror, about the lens, concave lens, convex lens, and the formulas. Okay, so this is the part 2. Okay, and we are going to start with the standard laws of convex mirror. First of all, first law: when a ray which is parallel to the principal axis, then it will be reflected back in the same medium in other side, reflected back in same medium on other side. But if you join the incident, this is the incident and this is the reflected. If you made an imaginary line of a reflected ray, that will be cut to the focus. It will cut the focus. And if you see that the incident ray and the reflected ray, they are meeting at a point, the normal is taken out and it is normal cutting to the C. So that is our first rule. I hope that is clear to you all. A light ray is coming and reflected back in the other side of the medium, and the reflected ray will cut the F. Now the second case. First case we have seen. The second case. In second case, the vice versa is there. When a ray is coming, so in the first law we seen that the incident ray is coming and it is parallel to the principal axis and reflected back in the same medium. But here the incident ray is coming from the other side, and after reflecting it will be the parallel to the principal axis, and as the normal will cut the C and the incident will cut the F. In previous, the reflected is cutting the F, while here the incident will cut the F. Now then the third case will be, if any ray is coming to the pole, touching the pole, then it will be reflected back in the same medium, having the same angle of incident and angle of reflection. Okay, so here is the third case, and the fourth case states when a ray coming from the outside and it reflected back in the same medium, in the same side, or in the same medium, or in the same straight line only. And if we made an imaginary line, that imaginary line will cut the center of curvature. And for easy concept, you can take the example like this. This is the sphere, this is the center of curvature. If you made, if the light ray is falling on it, this is the light ray, this is perpendicular. Okay, this is imaginary line, it is perpendicular to the surface. This surface is tangent, this is tangent, and this is the radius of curvature. And if you made, this is the 90 degree, then it is coming from the infinite to the C and reflected back to the C only. This is the fourth case. I hope that you understand that. Now we have done the standard laws. Now let's start with, so here we have done with the laws or standard laws of convex mirror. Now let's start with the ray diagram, and this is the most IMP concept. Okay, first, in the first case of the ray diagram, they are putting the object at the infinity. Let's put the object at infinity. We have put it the object at infinity. The rays are coming. This is the parallel to the principal axis. It will reflected back in the other side. This is also parallel to the principal axis. Then it will be reflected back in the other side. If you made that the imaginary reflected ray, then they will be concentrate at the focus. So the image will be formed behind the mirror at focus, not forward of mirror, behind the mirror, not forward, behind the mirror. Okay. And one more thing I want to tell, the convex mirror cannot form a large image, but is always forming small images. Okay, so here we have done our first case. Now let's start with the second case. In the second case, the position of the object is at any position. That means you can place the position at any place. Let the object taken to be on the principal axis at between C or F, between CF. Let's take it between the CF. Then first ray will be parallel to the principal axis and reflected back in the other medium. Then second, radius of curvature, I have told that if it is coming from the passing from the center of curvature, it will move in the same medium. Then if you made both of the imaginary line, they all are meeting at one point. And that point is this. You can see, for example, this is. Then students, let's take an imaginary line of the reflected ray. Imaginary line will always pass through the focus. Then a ray is coming from the imaginary line is coming from the center of curvature, and then it will be go to the center of curvature only. Then if we imagine one more line that is coming from the other side and reflected back and become parallel to the principal axis. Now imagine the incident ray, the reflected ray. They all are meeting at this point, meeting point of image. So the image will form between P and F. I am rubbing all the image that you can easily note down in your notebook. The image will form between P and F. You can see between P and F. So here are the 4 laws of convex mirror and ray diagram of convex mirror. Now let's quickly see about the lens. I have told in the starting only that in lens convex mirror is converging and concave mirror is diverging. Okay, then the types of lens are bioconvex, bioconcave, pianoconcave and planoconcave. Biconvex means a normal convex lens, and biconcave means normal concave lens. Now planoconvex means it is rounded from the one side and flat from the other side, while in planoconcave side one is flat and one is rounded other side. So there is a difference between this 4 mirror. You don't have to do this, they are the extra. Okay, now let's quickly start with law of convex lens. Laws of convex lens. So the first case tell us that if the all the rays are coming from the infinity, then it all will converge at the focus, only. Now the second case states that if any ray is passing from the f1, then it will be reflected, and not reflected, it will become the parallel to the principal axis, or main axis. Okay, if any ray is coming from the f1, then it will be the parallel to the principal axis. Okay, now start with the third case. In third case, if any ray is passing from the optic center is the middle part at the center of the convex lens. If any ray is passing from the center of the lens, which is optic center, then it will be the move in the same direction, in the straight path only. And here is the one exception, in which there is a fourth law which you have to study. Here I have not mentioned, that is my mistake. If any ray is parallel to the principal axis, and after refracted by the convex lens, it will cut the focus f2. So here are the four cases of convex lens. Now let's quickly study about the ray diagrams of convex lens. In the first ray diagram, what is the position of the object? Yes, at the infinity. See students, always the position of the object in the first case will be at infinity only. Now let's put the object at the infinity. All the ray are falling on the lens, and we have studied that the all ray will converge at the one point. Converge at one point. Okay, converge at one point. That's why the convex lens is known as converging lens. Okay, so here it is, they are converging. So at the f2 they are converging. So the image, students, I am talking about the image, not object. Image of the object will be formed at f2, at focus. You have to mention f2 only, not focus, because there are two focus, f1 and f2. They are different, so you have to say 2f2. The position of the image is f2. Okay, now let's start with second case, beyond 2f1. So don't be confused that the 2f1 is equal to center of curvature and f1 is equal to focus. You can remember like this. In the mirror, we told all the ray which are meeting at the one point, it is known as focus. Here it is known as f1. All the ray, the double of the focal length. We know the focal length distance between the P and F. The double of the P and F, that means double of focal length is equal to center of curvature. So here in the place of center of curvature, we are putting 2f1 is equal to 2 into f1. Okay students, I hope that is clear to you all. There is no any type of doubt in that only. Now let's move on to the second case. Second case, beyond 2f1. Beyond 2f1, that means beyond the C. Beyond 2f1, let's put the object beyond 2f1. If we put the object beyond 2f1, we have studied the fourth case in which, not a fourth case, second case in which a ray, incident ray is parallel to the principal axis, and after refracting, it will pass through the f2. It will pass through the f2, and one ray is coming from the optic center, then it will be passed through only the optic center only. Then the meeting point of both the images are this. So the image will form between 2f2 and f2. Between 2f2 and f2. Between 2f2 and f2. You can see between 2f and 2f2. Here is the second case. Let's see the third case in which we are going to put the object at 2f1, means at C. Let's put it. We put the object at C. Then one ray is parallel to the principal axis, refracted and pass through the f2 only. One ray is pass through center, optic center. Then the intersection of the both the point will be at 2f2. So the position of the object will be at 2f2. The position of the object will be at 2f2. So don't be confused, students, between the 2f1 and f1. Okay, so we have completed the three cases, and in the previous one, in the concave mirror, we know that there is a vice versa of object 1 to object 1 to object 5, object 2 to object 4, object 3 to object 3 only. Okay, so here is also the vice versa is there. So first of all, let's see all the cases, then I will be tell you the short trick to learn all the cases. First of all, put the object at between f1 and 2f1. Between f1 and 2f1, let's put it. One ray parallel to the principal axis pass through the f2. Second ray pass through the optic center. Then the intersection of both the point, it is at beyond 2f2. So the position of the image will be beyond 2f2. Position of the object will be always beyond 2f2. So, okay students, now let's see the fifth case. In fifth case, we are going to put our object at f1. At f1, first ray parallel to the principal axis pass through the f2. Second ray pass through the optic center. They are not meeting at any point because they are parallel. They will not meet. They will continuously go. So they will meet at infinite. The position of the image will be at infinite. Yes, infinite. So here is the fifth case, not a last case, fifth case, and here is the sixth case or a last case of convex lens. So we are going to put our object between f1 and O. Between f1 and O. What is O? We know the f1. F1 is focus. O is optic center. Optic center. I hope that is clear to you that O is optic center. Now let's see what is the sixth case. In sixth case, we are going to put our object at optic center, between the optic center and f1. So first ray is parallel to the principal axis, pass from the F2 only. Second ray is passing from the optic center, then it will be not, they are not going to meet at any point because they are parallel in these two. But if we think, much better and we imagine a imaginary line, we image a imaginary line of incident ray of optic center and incident ray of F1. They are meeting at a point, they are meeting at this point, and our image will be formed over this side. So our image is not forming on the right side of the lens, but it is forming on the left side of the lens. So the position of the image will be at, then the position will be at on the same side. Students, don't see this, there is a typing mistake. On the same side of the lens where the object is placed. That means object is placed over here, image is forming over here. So on the same side of the lens where the object is placed. I hope that is clear to you all. And congratulations students, here we have completed our last case of the convex mirror, and which is too difficult, but we have completed very easily. And if you understand the laws and the ray diagram of concave mirror, I am talking about the mirror only, okay, concave mirror, then you will not face any difficulties in remember convex lens laws and ray diagrams. Okay, I hope that is clear to you all. Now that there is a good news for you all, that I have made a short trick to remember all the 6 cases in just 2 minutes, for a lifetime. First of all, remember the part 1 video in which we have told the shortcut tree about the infinity to focus, beyond C to between CF, then at C to at C, then between CF to beyond C, then at focus to infinity. There is a vice versa. Here the infinity is there, focus is there in right side, but here in the left side there is a focus, in right side infinity is there. Here the beyond C is there in left side, in right side between CF, in left side between CF is there, while in right side beyond C is there. So this is the shortcut tree which we have made in the part 1 to remember the concave mirror. Here is the same trick will be going to be applied over here, but you just have to be focused, because in the previous one we have the center of curvature and the focus, but here we have F2 and 2F1. So if the object is at infinity, then the image will form at F2, that means at focus. If the image is forming object is on beyond 2F1, that means beyond C, then the image will form between CF in the concave mirror, but in the lens image will form between 2F and 2F2, between 2F and 2F2. Okay, I hope that is clear to you all. If the image is for object is at infinity, then image will be at F2, and if the object is beyond 2F1, then the image will be between F2 and 2F2. Now place the object at 2F1, that means at C, then the image will form at the C only. But here image will form at the C, but on the other side, that means at 2F2. Just you have to remember in 1 and 2, and for that I have also one shortcut tree to remember. So don't worry, I am with a full tooth planning to learn all the ray diagrams. Now let's see the fourth case in which we are going to put our object at f1. At f1. If we put the object at f1, then the image will be at infinity. At infinity. Okay, now the last case, the last trick to remember is if the object between the f1 and 2f1, then the image will form at 2f2. There is a vice versa, students. There is a vice versa. You can see in the left side infinity is there, right side focus is there, right side focus is there. No, in left side infinity is there, right side focus is there, left side focus is there, right side infinity is there. In left side beyond 2f1, right side between 2f and 2f2, while between f1 and 2f1, and in right side beyond 2f1. So there is a vice versa, students. There is a vice versa. So you just have to remember the three cases. You just have to remember the three cases, while the other three will be easy for you. Other three will be easy for you. First one is this, second one is this, then this is too easy, this is too easy. Just you have to put 2f1 and 2f2 only. And the last case is between f1 and optic center, same side of object. This is one exception is there, so you just have to remember by default. Okay, there is no any type of choice to remember a shortcut tree for this. So remember these three that I have told, 1, 2 and 3. Now for a shortcut tree, one more trick is there. If you have confusion in 1 and 2, remember in left side always 1 will be there, always 1 will, you can see 1 1 1 1 1 and also 1. And in the right side, that means right side, there will be always 2, always 2 2 2 2 2 2, you can see that. So there is a main difference between right and left. Left shows the object, the position of the object, and right side shows the position of image, position of object. Okay, so here is the shortcut tree to remember all the 6 cases. I hope that is clear to you all. Now let's quickly move on to the law of concave mirror, law of concave lens. So the first law telling us that if any ray is parallel to the principal axis, then it will be diverge and go in the far away from the principal axis. Second law is telling if any ray is principal in the downwards, second law is telling if any ray which is coming from the optic center, then it will be the go in the same straight line only, there it will be not move its path. And the third case is telling if any ray is coming from the far away from the principal axis, coming towards the principal axis and hit the concave lens, it will become the parallel to the principal axis. Yes, principal axis. So here are the 3 beautiful laws of concave lens. Why beautiful? Because they are very easy and simple to remember. One ray is coming from the infinite and become the parallel to the principal axis. Second law, which is coming from the center of optic center and going from the center optic center. And third one is the same opposite of the first case. That means ray is parallel to the principal axis and diverge into the away from the principal axis. Yes, students. Now let's see the ray diagram of concave lens. Ray diagram of concave lens. First of all, at infinity, at infinity, that means ray is coming from the infinity, it will diverge. I told in the previous that the law, if the light is parallel to the principal axis, then it will diverge in the other side and go away from the principal axis. Same will be there in the downwards. So if we made an imaginary line, see students, in the concave lens and convex mirror, in both of them the image will not form on same side as the five cases is there, okay. They will be formed in the different medium only, so there is one exception of that. So if you made an imaginary line of the reflected ray of one light and second light, then they are concentrate to the one point, and that point is f1. So the position of the image is f1, but on same side you have to write, on same side. And the second case, we are placing our object at any point. You can place the object at anywhere. Let's put the object at f1. Let's the object put at the at1. We have put our object at at1. Then the first ray will be always the parallel to the principal axis and diverge into the other side. And one ray is passing from the optic center, so it will be passing from the optic center, then it will be go in the straight line only. Then if we use our brain, if we made an imaginary line of reflected ray of first light, and if we see the second light is intersecting with the imaginary line of reflected ray of the first light, so this is the intersection point of imaginary reflected light of light 1 and of light 2, which is passing from the optic center. So image will form between f1 and O. If we put our object over here, then the same case will be going to happen. See, same case will be going to be happen. Okay, so you can put the object at anywhere. So here we have done with our law of concave lens. Here we have done with our law of concave lens as well as ray diagram of concave lens. Now let's see some important formulas for a lens. One formula is there for a lens. First of all, let me erase all the unnecessary things. Okay, so what we are telling, yes, let's see the important formulas. The important formulas are three formulas: power of lens, mirror formula, and lens formula. The mirror, first of all, let's see the lens formula. Lens formula is 1 upon f is equal to 1 upon v minus 1 upon u. 1 upon u. So this is the formula of lens, in which you have to put just a minus. And why, students, there is some glitch for that. In the mirror formula, you just have to put the plus. You just have to put the plus between u and v. And you have confusion in what is f, what is v, and what is u. V is image of height of image or a distance of image, and u is height of object or a distance of object. Okay, and f is the focal length. So this is the formula of lens and mirror. Now let's see the formula of power of lens. The formula of power of lens is 1 upon f. F is focal length. Focal length means the distance between the p and f. I hope that is clear to you all. Now the main topic, that is magnification. What is magnification? And this is the IMP topic, students, that it is asked in the previous board paper also. The ratio of the height of image, of and the height of object. That means the ratio of the height of image and the height of object. So the m means magnification, height of image, ratio means division of ratio means division, height of image is h dash, and height of object means h. This is the formula of magnification. You can put like this also: minus v upon u for mirror, and v upon u for lens. I hope that is clear to you. Let's see in the picture. Okay, here is the magnification, where the h dash upon h, which means there is a division into the lens and mirror, where the lens is v upon u and mirror is minus v upon u. I have told that. And what is m? M is symbol of magnification, and it has no unit. I hope that is clear to you. It has no unit, so you don't have to remember the unit of it. Now congratulations, students, we have done the hardest topic of our book, magnification, and the concave and convex lens and mirror. Now one more most IMP things is that sign convention. In sign convention, you just have to remember, if any object placed in the right side, it will be then the plus. This is mirror. In the right side it will be in the plus, and in the left side it will be in the minus. This is the principal axis. In the right side it will be the plus, in the left side it will be the minus. If the object is from beyond the, or you can say ahead the principal axis, then it will be the plus, or at the downwards of the principal axis it will be the minus. Okay, and here in this side, okay students, wait for a while. In this side over here, if any image is formed, it will become real inverted, and if image is formed over here, then it will be the virtual erect. So this is the one exception is there. I have mentioned over here also. Why I am writing over here? I have mentioned. You can go through here. You can go through this. Here we have completed our chapter number 9, light of class 10th. In two parts we have completed. In part 1 we have done the topics like the standard laws of concave mirror, the ray diagram of concave mirror, then the reflection, refraction, refractive index, Snell's law, law of reflection, law of refraction, bending tendency. There are 3, 4, 5, 6 laws are there. Okay, so here we have complete our full chapter. We have not just miss a single topic. And completed our chapter. If you like the video, then like, share and subscribe our channel. Let's meet in the next video. तब तक के लिए जय हिंद, जय भारत.